Tomorrow morning, you look up, and the familiar planets are gone. Mars is missing, Jupiter has vanished, Saturn's rings are nowhere to be found. But the real answer is far stranger. In their places, a world stolen from other star systems, dropped into the same paths around your sun. At first, the sky might look almost normal. Tiny points of light would still crawl through the constellations, yet the solar system would no longer be the carefully balanced neighborhood that allowed you to exist. It would become a gravitational experiment with no reset button. Start close to the sun. Replace Mercury with a scorching super-Earth like 55 Cancri E, a rocky world nearly twice Earth's width and several times its mass. From your backyard, it would still be difficult to see, but its gravity would tug much harder on Venus, Earth, and anything passing through the inner system. Would Earth immediately fall into the sun? Probably not. Gravity rarely works like a sudden trapdoor. Instead, every orbit would begin changing by tiny amounts. Those changes would accumulate. A small shift today could become a dangerous crossing millions of years later. Now replace Venus with a hot Jupiter. This is a gas giant packed close to its star, completing a year in only a few days. Put one in Venus's orbit, and the experiment becomes violent. Its mass could rival Jupiter's, but now it would sit next door to Earth. The night sky would be spectacular. The consequences would not. Each time Earth passed the giant planet, its orbit could stretch into a more oval shape. Summers could become hotter, winters could become colder. Over enough encounters, Earth might be thrown toward the sun, pushed outward, or launched into interstellar darkness. What happens if Earth itself is replaced? Choose a mini-Neptune, one of the common planet types your solar system lacks. It might look inviting from space, wrapped in blue clouds, but beneath those clouds could be a crushing atmosphere above a deep ocean or a high-pressure interior with no solid surface. Your cities would not be buried. They would never have existed. Now move outward. Replace Mars with an Earth-sized planet from the TRAPPIST-1 system. Around its original faint red star, that world completes a year in days. Around your sun, at Mars's distance, the same planet would receive a very different amount of energy. That is the hidden rule of habitability. A planet is not habitable by itself. Its star, orbit, atmosphere, rotation, magnetic field, and history all matter. Moving an alien world into your system is like moving a deep-sea creature onto a mountain. The creature may be extraordinary, but the environment that shaped it is gone. Then comes Jupiter. Jupiter is not just the largest planet you know. Its gravity has helped shape the solar system, redirecting comets, scattering asteroids, and influencing everything around it. Replace it with a smaller Neptune-like planet, and the asteroid belt could slowly reorganize. Some objects might become more stable, others might drift onto paths that cross Earth. Replace it with an enormous super-Jupiter, and the opposite problem appears. Its stronger gravity could disturb Saturn, pull comets inward, and amplify small orbital changes across the system. Would a bigger Jupiter protect you better? Not necessarily. A giant planet can eject dangerous objects, but it can also send them inward. Protection and destruction can come from the same gravitational hand. Now replace Saturn with a circumbinary planet like Kepler-16b, famous for orbiting two stars. The planet can be moved. Its two suns cannot. Around your single sun, it would lose the double sunset that made it remarkable. It would simply become a cold gas giant, carrying a history written for a different sky. That may be the strangest twist. The most exotic part of an exoplanet is often not the planet, it is the system around it. Some worlds circle red dwarf stars that flare violently, some orbit two stars, some race around their suns in less than a day, some travel on stretched paths between freezing distance and furnace heat. Drop those planets into your solar system, and their identities change. Drop enough of them here, and your identity changes too. The calendar depends on Earth's orbit. The tides depend mostly on the moon, but Earth's long-term stability depends on the wider system. Even the ingredients that formed your body came from a planetary neighborhood with a specific history of impacts, mixing, and survival. You think of planets as separate worlds, but no planet is truly separate. Each one is part of a gravitational conversation that has lasted billions of years. Change one voice and the rhythm shifts. Change every voice and the entire song becomes unrecognizable. So tomorrow morning, if you look up and the familiar planets are gone, the greatest danger would not be the strange new worlds themselves. It would be the realization that your quiet solar system was never ordinary scenery. It was the reason you were here to look up at all.